Hello, I'm Max Thorniley, and in this video I'm going to do my best at explaining Einstein's special and general theories of relativity, ideas that are revolutionary in our understanding of physics to this day. Firstly, I will delve into the theory and explain its two postulates: the lack of an absolute reference frame, since the laws of physics apply the same to all objects no matter their velocity, and also the constancy of the speed of light. Then I will explain the origins of special relativity through the work of various scientists beforehand, allowing Einstein to unify their work into possibly the most brilliant idea of the 20th century. Following on from this, I will outline the implications and significance of this discovery on our view of the universe. To begin with, light travels at a fixed speed, 299,792,458 meters per second, or roughly 3 times 10 to the 8 meters per second. This is independent of whether its source is moving or not. The speed of light still stays at 3 times 10 to the 8 meters per second. As I said before, this is the second postulate of special relativity. Obviously, light is strange in this regard. For example, think of yourself standing on a train with a tennis ball in hand, and your friend is in front of you. If the train starts moving backwards at an arbitrary speed, and you throw the ball at your friend, the speed of the train will deduct from the speed of the throw. The opposite is also true. As you move towards your friend, the speed of the train will add to the velocity of the ball, and now you have yourself an enemy. In this way, light is different to ordinary matter, and this is the basis for special and general relativity. I hope you are all familiar with this triangle. If not, it basically means that distance is the product of speed and time, speed is the quotient of distance and time is the quotient of distance and speed. But what we want to focus on is speed, mainly the speed of light. Here is Jeff in his spaceship with a torch and 2 mirrors. He shines a beam of light at the bottom mirror. It is then reflected directly upwards and back down again. Therefore, Jeff perceives the light beam making one straight line up and down. Now here is Lucy outside the spaceship, which is moving at relativistic speeds, looking at the beam of light as it is reflected. Because of the movement of the spaceship, the mirror has moved before the light hits it and reflects back each time. Therefore, Lucy perceives the light to make a diagonal path upwards and downwards. We'll call the up and back distance that Jeff sees d, and the up and back distance that Lucy sees d2. We can obviously see that d is not equal to d2 from the angle of the lines. Therefore, in order to make d2 over time equal to the speed of light, we need to have varying time values as well. This change in the passage of time is called time dilation, a consequence of relativity. When something is moving, for example Jeff's rocket ship, it warps space-time in such a way that keeps the speed of light constant. In a similar way, unlike on the train, no matter what velocity a light source is moving at, the light travels at the same speed. Again, this comes down to relativity. The velocity of ship A is different to that of ship B, but if light must travel at a fixed speed, space-time must be warped in order to allow this. Now I will talk about the first postulate of relativity, once again using Jeff and Lucy. The reason I explained the second postulate first was because it helps give a bit of background. This postulate is the lack of an absolute reference frame, since the laws of physics apply to everything, no matter the velocity of the object or the observer. For example, take Universe 1 and Universe 2, with Jeff in one and Lucy in the other. How would you know that Jeff just moved if you hadn't have made a reference to the markings on the board itself, or the screen you're viewing this video on, or anything else for that matter? In a similar way, in this one otherwise objectless universe, how would you tell Lucy moved without relating the movement to Jeff? For all we know, Jeff was the one that moved in relation to Lucy. It is for this reason that earlier, Jeff and Lucy had 2 different observations for distance and time, yet both were absolutely correct. From the 2 postulates of relativity, we can see that space-time is dynamic and is molded by mass and energy applied to it, much like a balloon. To recap, Einstein, with his theory of special relativity, brought space and time together and proposed a dynamic, 4-dimensional space-time continuum that moved and warped distance and time to keep the speed of light fixed. Now I'm going to briefly explain the scientific findings that led up to the theory of special relativity. It all began with Galileo and Newton, who you may have heard of before. The way they influenced relativity was by implying that there was no absolute space, a finding that is fundamental in relativity, through their work towards understanding gravity. Unfortunately for Newton, he disagreed with this implication as it conflicted with his idea of an absolute God, even though it was shown in his laws of motion, saying that an object moves at a constant speed, a force only changes the velocity of the object. Now this implied that there was no absolute space. We also know from special relativity that there's no absolute time. Well, in 1676, old Christensen Romer discovered light speed was finite. Then, much later, James Clerk Maxwell theorized the electromagnetic field that light and other electromagnetic radiation moves through at a fixed speed. In 1887, Albert Michelson and Edward Morley discovered that light speed was independent of the velocity of its source. And finally, in 1905, Albert Einstein unified these findings into special relativity, and a bit later proposed general relativity. And, as we already know from special relativity, there is no absolute time. These are two implications caused by special relativity. I'm putting the implication and the significance section together since the implications are quite significant. Anyway, another large implication was for the Newtonian theory of gravity, since it implied that the force of gravity moved infinitely quickly, and this was not permitted by special relativity. It took Einstein another few years to formulate general relativity, a theory that incorporated gravity. General relativity added on to special relativity, as it showed that gravity could also affect spacetime. It basically makes a 4D indent into spacetime, infinitely covering every possible angle. Finally, I will explain relativity's significance and impact. Special and general relativity have not only provided a basis for our current view of the universe, but have also helped us tremendously with new technologies, namely satellite navigation systems. Earth's mass causes time near it to slow down, so things further away have faster time, for example satellites. Imagine a light beam being shot upwards from Earth. Earth's gravity doesn't change the speed of light, however it does cause it to lose energy. As a consequence, the frequency of the light waves decreases, in turn meaning that there are less waves per second, and therefore time seems to slow down. Another way to think of this is again imagining the sun making an indent in spacetime. As the sun does this, it stretches spacetime, but in our three-dimensional plane, we don't see the differences in the stretching, but we must travel further on the surface in order to move the same amount above the surface. This stretching occurs in every other angle, as I said before, so time appears to slow down. In summary, we learnt in this video what special and general relativity are, what spacetime is, and how speed, time, and distance change to keep the speed of light fixed. We also learnt the origins of relativity through the scientists that played a part in the discovery of relativity and the revolutionary concepts involved. Finally, we learnt the implications for Newton's theory of gravity and Newton's ideas about absolute space and time, the new way scientists view physics, and the help given towards new technologies. Thank you for listening. I hope you enjoyed my video.